Hello! Number 16 is a classic conservation of momentum problem. I don't know if y'all got to momentum, and if you're going to have momentum on your test. If you're not, you can skip this one. But if you have momentum, if you've heard that word, if you're like, yeah, I think I'm supposed to know what that is, follow along. Okay, so we've got M1V1, so that's like the block, or the bullet, plus M2V2 equals M final V final. The subscripts are going to be real important here. Okay, so momentum is conserved. Momentum before equals momentum after. So momentum of the bullet block system before has to equal the same as the momentum of the bullet block system after. Okay, so I'm going to put bullet and block on both. They all start with the letter B, which is annoying. So mass of the bullet times the velocity of the bullet plus mass of the block times the velocity of the block equals the mass of both times the velocity of both after the collision. Anytime you see the word collision, you should be thinking conservation of momentum. Okay, momentum before equals momentum after. Okay, so the mass of the bullet is 0.020. The velocity of the bullet, did they give that to us? No, we're looking for that. Okay, V bullet plus mass of the block, which is 2.98, times velocity of the block, which initially is 0. Before the bullet hits it, it's just hanging there. Okay, add the mass of both. You just add them up, so 2.98 plus 0.020 times the velocity of both, which they did not give us. So we have one equation with two unknowns, the velocity of the system and the velocity of the bullet. One equation, two unknowns, we cannot do that. You need the same number of equations and unknowns. So since they're asking for velocity of the bullet, we should probably figure out the velocity of the system so we can solve for that bullet. Okay, what have we not used yet? The vertical distance. Okay, so we have this block and bullet, which the moment here that they hit each other, that exact moment, we're going to take our snapshot. We're going to do a law of conservation of energy problem. Loco. This over here is law of conservation of momentum. Locum. This is loco. Law of conservation of energy. So we're going to do before, like energy before equals energy after. We just have to be really clever about what we call before and what we call after. I'm going to choose the moment that they hit each other because that's the moment that they want to know the velocity. So it's a handy moment. Okay, so that'll be all kinetic when they're just like hitting each other. I know it's not on the ground, but this 0.049 isn't relative to the ground either. It's relative to like here. So we're going to call this the ground and make it easy on ourselves. So we're going to say that this is the ground, which means we have only kinetic energy. Isn't that handy? And then later, when we're up in the air, yep, it's just gravity. It's not moving anymore. It's changing direction. So all that kinetic has to become all gravitational. So let's do that. So big K, the formula is 1/2 mv squared. The formula for gravitational potential energy is mgh. There's m's on both sides. You can cancel them out or leave them. It doesn't matter. Velocities, what we care about here, gravity is 9.8. And the height they said was 0.049. So one equation, one unknown. Let's do this. 9.8 times 0.049 divided by 0.5 and take your square root. Ooh, oh, I hit a button. I talk while I calculate and I shouldn't. Until I figure out how to get a camera on my calculator, I will awkwardly keep talking while I do that. So that velocity is 0.98. Ooh, if I was your teacher, I'd be mean and make 0.98 an answer choice. Okay, so instead of that, we're going to put 0.98. Okay, so let's add those up and multiply that. See, that calculation I stayed quiet. I did it right, but like I feel like it was awkward between us. I don't know. This goes to 0, so we don't need that. So then we divide by 0.02. And I got 2.9. Oh no! Ugh. See, I talk while I do this. I think that 0.98 is right. Oh, it's plus. I see what I did. Okay, so that ends up being 2.94 on this side. divided by 0.02. Now it's 147. That's the way. Yeah, when you're taking your test, don't talk for a couple reasons. You're not allowed to. I can't have you looking like you're lying, cheating, or stealing. As an Aggie, I cannot tolerate that. But the velocity should be 147. If you have to write some of those steps down instead of doing it all on your calculator, you do you. You do you. You're not graded on any physics after this step. So don't feel like you have to show work that like you're doing in your head. Okay, 147. Let me double check that is the answer. It is. Sweet. Okay. One down, lots to go.